Thank you. And following on with Richard's memory approach to things, let's see what's going to happen here is we're working in short-term memory. So there'll be a primacy effect for Richard's talk. And there'll be a little bit of loss, and then there'll be a recency effect for my talk. But that's short-term memory. And tomorrow, we'll have the negative recency effect, which will mean you'll forget my talk. And it also means that you're also thinking about lunch. So I'm going to move very quickly and loudly so that you don't forget me. Okay. So I think we went on to the... Let me go back a slide. Yeah. So I'd like to talk to you today about recording brainwaves in the supermarket. And as you might suspect, there's some special challenges associated with that. And it is technically a difficult thing to do, but it is doable, which we're conducting a national study using eye tracking and EEG in the store. And let's see if I can find the laser pointer here. Here we go. The technology that I use is very similar to what Richard is doing, in the sense that I'm recording spontaneous EEG. He's doing something called steady-state topography, which is actually probably a pretty good technology for doing this mobile stuff because it's very robust in terms of artifact and so on. But what we do is record traditional EEG from a large array of channels. The reason for all of those channels is I also use a technique called source reconstruction. That is, I attempt to localize the electrical activity of the brain from those sensors. It's very similar to earthquake localization. If you have a lot of sensors around a spherical structure, you can perhaps figure out where the epicenter of that was. The problem is in the brain there's lots of epicenters going on at the same time, and many times they overlap with one another. And so that presents also some special problems. But effectively I do things very similar to what Richard described, in the sense I'm looking at emotional valence from the very same structures that he talked about, looking at the left and right, asymmetry, we're looking at memory and attention and recognition from essentially the same neurological structures. It's nice to see concordance in research, isn't it? Okay, so we're truncated up there. So there are some special challenges, as I mentioned, to recording EEG while someone's moving about in the field. They are free in our studies to walk about. There is no tethering or anything like that attached to this. No one's walking around behind with a notebook and watching their EEG and saying, "Oh, be careful, don't move now." They're freely behaving. The backpack that they're wearing has a notebook in it that's recording their eye movements, and we have a few devices for recording the EEG as well. Now, the other things I want to just emphasize is to do this effectively, you really need to have the impedances, and technically for the EEG it has to be very low because the artifact and movement artifact and eye movements are massive and not easily removed. So what do we use to do this? We have a small EEG amplifier that we put in the backpack. We have a couple of these things. And we record their EEG, and that is synchronized with their goggles. And we use a pair of binocular goggles that allow us to tell not only where the subject is looking, but also the depth of field for that. And that's also a very critical thing, because when somebody looks at a price, we need to see that they are looking at the price or they're examining the product. And if they hold it up close to them, we need to handle the parallax problem, so that we can see that they are reading the label and see exactly what they're reading. And because for us, what we're going to do is time lock the eye movement data with the EEG precisely. And so our methodology to handle this is to create something called an evoked response that's associated with an eye fixation. And there are a lot of fixations that happen in your everyday world. As you're making about 3 every second on the average. And most eye fixations last about 200 milliseconds, and we can record those. Now, in terms of the preparation of an individual that's going to go out in the field, there are obviously some special concerns. One of them is just simply anxiety. You could imagine walking out into the store with a cap on. And then that's always the number one question: are people going to notice me? I'm wearing a hat, but I've got these goggles that make me look like a board, and and people are going to stare at me, they're going to laugh at me, and so on. That actually doesn't happen. On the average, there's maybe 1 to 2 observations where people actually look at you. Of course, there are furtive eye movements that people make a glance and say, "Oh, this must be a patient or something." But for the most part, there's no disruption in their behavior, their natural stuff. And we record their galvanic skin responses while they're in the store as well to look for emotional changes. And yes, when they start to walk out with their cart into the store, anxiety is high. You would expect that. I remember I did it several times myself, and honestly, I sort of felt funny too. People were looking at me. I thought, well, they must be looking at me. But, they aren't. People are remarkably unaware of what's going around them in the store. They're focused on buying products, and only occasionally, with the exception of kids, they're going to notice it. Now, the other things that are really important for this recording is we really need to make contact with the brain. We can't afford to have artifact come in from standard things that actually a lot of EEGs are starting to forget about. And that's this transepithelial potential that rides on the skin. It's very large. And when you walk around and you touch things like this, if I were to touch this table and I was hooked up to an EEG machine, I would, without good impedances, it would go nuts. So we really need to remove those dry layers of the skin very gently. Okay. So, so far we've recorded about 250 subjects in the field. We've looked at about 8 major markets, and in each major market, going from the east to the west coast, we typically study at least 2 to 3 stores within a region. So, for example, if we decide to go to San Jose, we'll be looking at 3 stores in the Bay Area in California, and so on. We looked at a lot of stores in highly dense areas such as Boston and so on. And so a lot of our focus was on both the east and the west coast. Now, I talked about the eye fixation, so as a result, what we're left with is a data set with specific eye fixations on products, not navigational eye movements or looking at somebody walking down a hall or anything like that. These are categorized by humans looking at videos as relevant fixations to the purchase. And we've so far looked at 17,000 eye movements individually. And there's no nice way to do this. You have to do it. There is no computer that can tell you yet that says, well, they're holding up a can of soup and they're looking at this. Okay, then we further have to go through and analyze whether they purchased it or not. So what that means is going through all of that video and saying, okay, that went into the cart. They really purchased that can of soup. They put it in there. Now let's roll back and see if we can find the first eye movement to that purchase and follow the pattern of eye movements that result in an actual purchase. Now, of course, there's plenty of fixations that have to do with looking at a potential product and rejecting that product. So we look for exploratory behavior while the individual is in the shopping scenario where they're exploring products next to the target item and so on. And the other things we're going to look at are whether someone, what happens when you grab a product. Of course, we're going to look at what happens when you put it in the cart. Then there are a lot of times when people put it back on the shelf. Those are, of course, quite of interest. And finally, we have analyses where the people are really going in depth and looking at the label and what goes on during that. Okay, so first I want to just talk about the top level findings for the eye tracking. And one of the big results is that most people think when they go to the store that they're very directed. And again, this is the self-report problem. So, well, what do you do when you go to the store? Well, I go right to the product I'm interested in. And if it's a male, they're even more certain about that. I go right to it, I pick it up, I don't look at anything else, and I go on. And that is simply not true. And there's no difference between males and females on this particular behavior. The vast majority of eye movements are actually exploring other products. That is consistent with a major finding that was brought up maybe almost 15 years ago, that about 70% of purchases are made in store. This was gleaned by asking people before they go in the store, what are you going to buy today? And then interviewing them afterwards to see what they actually bought. And one of the things that became immediately obvious is that there's a lot of impulsivity going on. And people have very strong opinions about their impulsivity in terms of what they were going to do versus what they actually did. And this is consistent with that finding, in that most of the eye movements that we look at in purchase situation are rejections, where they're looking at other products. And what that means is, if you don't find the product of interest, there's tremendous opportunity for competitors to get those eye movements. It's really not a closed situation at all. There's tremendous opportunity for exploratory behavior on other products. And just to mention an example, a perfect scenario was Tropicana a while back changed the look of their package. And they almost tanked because of that. The brand really lost market share. And what had happened in that scenario is they changed it enough so those exploratory eye movements around the shelf trying to find the orange juice grabbed a hold of it, and no more Tropicana being bought. So this is not something to be taken lightly. The other thing that really pops up in this large study is display technologies and so on. There's it's $1 billion industry in the United States, or multi-billion-dollar probably, to make displays and so on. Do people spend time looking at these displays? The answer is a weak yes. 5% of all the eye movements we look at are related to displays. That is, if you're shopping and you're walking down the aisle, it's more likely that you're going to see that display as an object. There are many more scenarios where you're just trying to navigate around this object. Now that's huge, because the advertising, below the line advertising industry makes its living, and retailers make their living on these displays and selling those displays for as a special offer and so on. And unless the display, and I'm going to get into that in later talks about how the type of displays that really work, unless it's really a unique display, it's likely to be ignored. For example, if it's an M&M dispenser and it's a little M&M guy, people are going to look at it. But it takes a lot to get over the ignoring threshold in display technologies for that. And really, you ask, well, don't people already know this? And the answer is not clear, because there really hasn't been a large study with eye tracking systematically looking at what people really look at in the store. Okay, so that's some of the overall behavioral results. And now I want to talk a little bit about the brain responses when you do make those eye movements. And the largest effect that we have found so far is that the emotional valence associated with that first eye movement to the product that goes into the card is the biggest predictor of whether it's going to go in. And it's consistent with the previous two speakers. I'll just jump ahead and tell you it's the correlation coefficient, or the R, is 0.51 for the difference. And it's really lovely to see, okay, we're all looking at this. And the stated preference correlates at about 0.2, also consistent with previous work. So if you ask somebody, what are you going to buy, which we have, and then you look at the card and see what they actually bought, the correlation coefficient is 0.2, very low. And now, I've simplified this quite a bit. When we're talking about emotional valence, what I'm talking about is the difference between the left and the right frontal lobe. And the way that I compute that is I calculate the response from what's called a regional source placed in that region of the brain, the left frontal and the right frontal. I'm looking at very slow responses, and I'll show you an example of that. But it's essentially built on the same thing that Richard mentioned, the Ritchie-Davidson effect, discovered in 1975. And there's hundreds of papers on this particular topic, looking at primarily alpha asymmetries. What I've done is look at specifically the very slow frequencies, the ultra slow frequencies, down below 3 hertz. And I model those frequencies and look at the difference. And so what this result shows, of course, the biggest effect for whether someone's going to put something in a cart is the first eye movement evoked response to that product. Subsequent eye movements are not as predictive. It's really the first eye movement. What that tells you is the reward sequence in purchasing is really that first fixation. So when the product is identified, and that's how fast it happens. Getting back to the speed that's necessary to track decision making, whether it be in an fMRI scenario or an EEG scenario, you get into rapidly diminishing returns the more time transpires between the two events. So whether you're looking at a commercial or whether you're looking at whether or not someone's going to put something in a cart, you better be able to handle 100 to 200 milliseconds. Otherwise, most of it's going to be gone by the time the purchase is actually made. Okay. So let's see if I can play a movie here. This is a purchase, a very rapid presentation of what this person is about to put that product in the cart. And what we're looking at here is a measure that's effectively overall brain activation, very similar to what the previous talks they brought up. We're looking at the total brain activation, and then we're looking at the asymmetry between those two. This is the time-locked cortical brain electrical activity, looking at it from 6 different views. So that's the event, and I'll play it a couple times because it's hard to see on the screen. But basically what you're looking at, you'll see a little square that moves around on the screen, and that's what we're using. That's the eye movements. Eye movements are very fast, and we have to go through frame by frame of each individual eye movement and identify the actual eye movement, which was the first eye movement to the product. And the brain response, which you're looking at, is an aggregated response. We're not capable of doing this on an individual subject level. We're far from that. So everything I'm talking about at this point are group effects. Okay, what happens when you reject a product? Well, we still get activation, but we have a reversal of the asymmetry between the left and right frontal lobe. You see the subtraction has gone negative. And so all of those, 82% of those 17,000 eye movements that I'm talking about, the emotional valence for that is 14% the other way. Okay. So again, if I look at the eye movements where they evaluate the product and then they decide not to buy it, we get a negative emotional response to it. And here's an example of that. Okay? So the individual's looking at looked at something that's in the freezer. We identified what that product is. We've identified every single product that everybody has looked at. We have a huge database of all of that information. So at the product level, which is going to be very useful as we go forward. And now we can start to ask some basic questions about, we can say something about the eye movements, but what does the neural tell us that the eye movements can't? And so here we're looking at some various categories of food items. Ignore the colorful one. It's from another study. And guess which one is the highest, the most activating stimulus out there? You guessed it. Alcohol. There's a lot of other anecdotal stuff that goes with it when you're really tracking people in the store. We see a lot of behaviors that have to do with really, shall I say, fondling the product. Wine labels are treated differently. We'll look at that. We'll examine it very closely. The time on task with that is really quite long, if it's a particular one. And as we go up, we're really in the hedonic food items up in here. And as we go back down, we get down to the basics and so on. So that's very interesting. And then we also look at time in the particular category. How long do people spend in that category? Well, there's an inverse relationship between this. And that's very interesting. If you take a look, how much time are we spending in the candy aisle, one of the top items? Very little time. So, if I may make an inferential leap here, we're running the gauntlet of the candy aisle. And we're just going through it, but we are being stimulated as we're going through. And there are a lot of eye movements, and I'm sure that started at 3 years of age. 2 to 3 years of age. Candy's placed very low in the supermarket, isn't it? Okay. So, what is the predictive value for all of that? 0.05, right now 0.5, but it's getting more and more significant at least a 0.01. I think it's even higher. But a close second behind that is activation of the visual cortex. Visual cortex, precuneus, same structures that we're talking about before, we're seeing that activation. And then right behind that is frontal lobe, overall frontal lobe activation, which I'm sure has to do with both memory, encoding, and higher cognitive processing. Oops, I'm missing a few slides. Okay. So that's where we stand at with the study, and those are the main effects. We're able to predict whether or not somebody is able to put something in a car simply by looking at their eye movements and analyzing the activity right after that. So I'll keep this talk short, and we are just about out of time, and maybe at this point I'm ready to answer a few questions you might have. Thank you.